So welcome to this new video. This is a project that I'm working on. This is a servo setter for my model railway. Now I've just done a tutorial on how to use the PCA9685 servo driver board, and that's what I'm going to be using in this project. I'm also going to be using it in some future projects for some DCC decoders to control my servos for the points on my layout, and this project is part of what is required to get to that goal. So for those who've not done projects, just a little bit of advice on starting a project. The first thing is to define the goals of your project. One of the great dangers with all projects, you can get project creep on them. I used to get this in industry where you'd build something and someone would suddenly go, oh, can we add this? Can we add that? Well, you can add anything, but it's going to take time and it's going to cost money. This is one of the dangers with a project like this. So in this project, I've actually built this project on a breadboard. I've only got to set 8 points or 8 turnouts. So I haven't even bothered soldering this down. There's just no need to do that. If I was going to do 20 or 30, then I would solder this to a bit of Vero board. And I'll be honest, if I was going to do that many, I'd probably add an LCD screen as well. But because I don't need that, because I'm only doing a few points, I've kept this project as simple as possible. And I'm hoping by doing that, that you'll be able to understand a little bit about how the code works. This code has to be written in a way that the buttons can be pressed at any time without interfering with the code. So this is using sort of what we call state machine code, so it doesn't use delay within the code, because if you use delay you lock down your code and nothing will work. So that is the overview, if you like, of the project. Let's have a quick look at the project circuit. So this is the circuit that we're going to be working with. Obviously I'm using an Uno here. Pick your board of choice. You've got the PCA9685 board to the right, and below it is a servo. I've only got one servo and it's attached to port 0. I've got no need in this project to attach it to any other ports. And I'll be honest, although I've got the 5-volt supply listed in here, I'm actually putting my 5 volts into this pin here because I know I'm never going to use more than one servo, so I'm not going to overload it. So that is the PCA9685 part, which you can read about in the project that I did the other day. There'll be a link at the bottom of the web page to do with this project, and at the bottom there'll be links to various other projects that will help. We've then got 4 buttons along the top. Now each button has a pull down resistor that's going to ground. For those who don't know about pull up or pull down resistors, they basically keep the signal very clean. If a pin is not sort of high or low, it can do what they call float, and you can get some really weird effects from that. Suddenly it can look like the button's been pressed when it's not been pressed. So we use a pull down or pull up resistor to keep the pin state steady. And this one we have, if you like, you can see where we're connected from pin 8 to one side of the button, and at the same time that goes straight to ground, and then across the button we can go back to 5 volts. So the button is held to ground while the button is not being pressed. As soon as the button's pressed, the circuit is made and it connects to 5 volts and the pin goes high. So in this code we have 4 buttons. The button on the right is what I call the mode select button. This decides if the servo is being forced to 90 degrees, that's its central position, or whether it's in what I call sweep mode, where it's going sort of left, right, left, right, left, right as I adjust it. The reason for having those two modes is when the project starts, it's in 90-degree mode, so that the servo instantly goes to its center position. If I just scroll down to this photo, this is a photo of the hardware side, and you'll notice there's no arm on the servo. That's because I've just attached it, and I'm not going to put the arm on until the code has started and it gets set to its central position. So that is, if you like, the mode button. Then I've got a second button, and this decides whether I'm adjusting the, what I would call the low side of the sweep or the high side. The low side, for the purposes of this tutorial, is the side of the sweep action that is closest to 0 degrees, and the high side is the movement that's closest to the 180 degrees, the other end. Now with this one, I can press the button to select whether I want to be adjusting the low side or the high side, and then of course I have two more buttons here, one which adjusts the high side or the low side, the height of, yeah. Oh, this gets complicated. Basically, it increases or decreases the angle at each side depending which the button is pressed. It's easier to show you in the code than explain it. So going down, some of the things that you need to know, there are the various connections for the PCA9685 board. Not going to go through those because they're in the other tutorial. This is what my finished board looked like, just the wiring jungle. And this is the hardware that I'm actually working with. So I'm using an MG90. You'll often see the sort of blue colored servos. Those are an SG90, I believe it is. The only difference between the two is these have metal gears. So I'm hoping it will last a little bit longer. Now, what I've done is on the layout, I drilled a 9mm diameter hole directly below the tie bar on the point or turnout. The idea then is there's a 1mm hole here, and a piece of wire is going to go through, be attached to the servo arm, and as the servo arm swings backwards and forwards, it will make the point change direction. This is all part of a bigger project. I'm upgrading the way that my points are controlled. Up until now I've had the servos mounted the other way, so it's a much longer distance that the servo arm is turning, and I'm not so keen on it. I just want it so there's less, if you like, flex in the system. The way this servo is mounted to the board, you may just be able to see it is in a little bracket. These are 3D printed. This is the first one that I've tested. It's just on a piece of wood just to see how it worked. And good job it is on a piece of wood, because I fouled up. I forgot that the servo arm is not in the center of the servo, which means this screw is fine. It's to the one side of the track, but the screw that would have gone on the other side would go right through the center of the track. And I do not like screws going up under where I have track, because it can cause problems. That's the reason why these screws are so far apart. They're guaranteed to clear the track and not cause any distortion. So that is the hardware part of the project. Now let's get on with the software. Now, if you haven't seen the tutorial I did on the PCA9685 boards, let's just start at the beginning. Test, test, and do more testing. You know, when we build these projects and we stick all these wires in the breadboard, it all looks great. But these wires aren't always the best. Sometimes the connection's a bit dodgy. So there's an example that you can go to in the Arduino IDE that allows you to scan to make sure you've got an I2C address for your PCA9685 board. I've explained that in the other tutorial, and of course you need to make sure you've got your libraries loaded, and again it's good to run one of the examples just to make sure that you've got all your connections correct. If you don't do that sort of thing, you're going to finish up later on running into some problems trying to figure out what's wrong, and you're going to find out eventually that you've got a bus wire after you've spent hours and hours trying to rewrite your code that actually had no faults in it. So test your wiring, test it again, test it again. Work through a process. Don't try and do everything in one go. So now we're going to come to the code. Let's just get the different windows up. As you can see, here is the output from the last job I did, and you can see that the low side needs an angle of 81 degrees and the high side is 121 degrees. Quite happy with that, and I was getting a really nice movement. I'll show you a bit of video of it in a moment. So that was the unit in action. As you can see, it's not particularly spectacular, but it's doing the job. So I'd already had the servo set to 90, put the servo arm in, bang square with the point blades in a center position, and then of course I started to use the adjuster buttons to the left and the right to adjust it. So let's go through the code and then I'll show you it running in the serial monitor so we can see how it works. Now, various pins, as pin 8 is the mode, pin 9 whether I'm adjusting left or right, which is sort of the high or the low, and then you've got a pin that makes it lower and a pin that makes it higher depending which side we're going. Now, from the PCA9685 tutorial, these are the settings of the board here. Don't bother touching them unless you know what you're doing. Again, if you go into the other tutorial, you could have a different address if you've soldered one of the pads, in which case you're going to need to use a line like that. But these basic settings in here, just leave them alone because they work fine with this type of servo. Now, for the 4 buttons, I've got the mode pin, pin 8, adjust pin, pin 9, low adjust pin 10, high adjust pin 11. I've then got one servo which I'm plugging into position 0. Again, you'll recognize some of these bits of code from the last tutorial. Now, there are some various system variables that are required within the project to make it work, as you'll see. We've got the current mode, so it starts off as 0. That means that it's going to be trying to set the servo to 90 degrees, its center position. If it goes to 1, then it's in what I call sweep mode, moving it left to right. Adjust side, 0 means I'm adjusting the low side of the sweep, and 1 means I'm adjusting the high side. Then we've got an unsigned long, current millis. This is a variable that I use in most of my projects. If we go down to the main loop, it stores the current time in milliseconds since the board started. I tend to use it as a global variable, then I can use it all over my code. We've then got another unsigned long, which is the button timer, and this is storing the value in milliseconds that the button was last pressed, so we know if it's can be pressed again because the button needs to be debounced. The reason the button needs to be debounced is that if you don't debounce the button, you could press the button what you think of pressing it once, and you're actually going to press it 200 times because the board is working so fast. If you don't understand the debouncing of buttons, again, if you go to the tutorial page on the website, there's a link to debouncing buttons at the bottom. Now, coming back to our code, we've got a sweep timer. I'm moving backwards and forwards every 2.5 seconds. I didn't want it to go any faster. I need to be able to see it. I want it slow enough that I can see what's happening, but fast enough that I'm not going to be waiting all year. And then we've got a sweep direction, a sort of clockwise or anti-clockwise, a sweep low limit and a sweep high limit. This is how far it's going to move in its low direction and how far it's going to move in its high direction. We're going to start with both of them at 90, and then as we press the buttons, we'll adjust them in each direction. Now, coming down to the setup, get the serial monitor running, we've then got this bit of code to do with setting up the PCA9685 board. You don't have to worry about it, just leave it alone, it'll be fine. There is then one tiny delay. It's a minute delay, but it's in there just to let everything settle down and make sure the board is ready. Then we've got the various pin modes for the 4 buttons. All of them are inputs because obviously they are buttons. And then we come down to the main loop, and you've got to admit that is a pretty empty main loop. So at the beginning of the loop, it gets the current time in milliseconds. We've then got a function that deals with buttons, and then we've got a function called servo mode, which tells the servo what it should be doing. Now, what I'm going to do first is do servo mode, just because it's a little bit easier to start with. So, servo mode. If you remember, our servo value is in this variable current mode. Now, the current mode is adjusted by the button on pin 8, and if the current mode is less than 0, which is what it will start at, any servo attached will instantly be set to 90 degrees. So you can now fit your servo arm in place, and knowing that the servo is fully centered. Obviously, if you then pressed the button on pin 8, it will change the current mode to a value of 1, in which case it goes into what's called normal sweep mode. Now again, there is a timer, and what it's doing is it's saying if the current time minus the servo sweep timer is greater or equal to the sweep timer. Again, this is how state machine code works. I've done a separate tutorial on that, so go through it a little bit more, but it's basically saying if it's now time to do the next sweep, do the sweep, and now reset the values so that we're ready to check again. This is obviously a value of 2500, which is the time between sweeps. Then what it's saying is if the sweep direction is smaller than 1, move in a direction, and if you'll notice it sets M equals M low, and then it gives the sweep low limit. Now if we look at the value that I was running, that means that it is aiming at this point in the code for 81 degrees. When it moves in the other direction, we get M high, and that's telling me at this point it was aiming for a value of 121 degrees. Those are the values that I've set using the adjuster buttons. And of course, once it's gone, if that's smaller than 1, basically value is 0, it'll set it to 1, and if the value was 1, it sets it to 0, so that it goes round and round in a loop, just sweeping backwards and forwards. So that's how the sweep system works. So that's controlling the servo itself. And of course the important thing about the servo, when we send the instruction to the servo, my servo, we've selected port 0, so we had that value for my servo is 0, and then sweep left limit or sweep low limit or sweep high limit is the value, the angle that we want the servo to move to. Now this function sets servo position. If you go to the last tutorial I did, it's a function that I wrote to make this library, the PCA9685 Adafruit library, behave a little bit more like the traditional Arduino servo library. The only difference was, instead of just sending the position, you also have to send the servo number on the board. And there's a bit of code in here that does some little checks to make sure you're not trying to do something silly with your servo. But again, that's in the last tutorial, so if you want to understand more about that, check out the last tutorial. Now, the only other bit in the main loop is the button state. So let's take a look at this button state function. Now, I've tried to keep this function as simple as possible. It could have got Project Creep, and I could have put debouncing on each button. We'd have had debouncers all over the place. I didn't do that. I kept this simple because in my view, with 4 buttons, you should never be pressing more than one button at a time, and if someone does press more than one button, it's only going to read the first button and then move on. So let's have a look at how the code works. So we've got the debounce, so if a button's been pressed, it's going to wait a small period of time before it takes a value again. The first thing we're going to check is the mode pin. So if the mode pin is high, that means it's been pressed. So if the current mode is greater than 0, which means it's in sweep mode, we're going to put it into mode. It's going to set current mode to 0, and it's just going to move to 90 degrees. And I've put a serial print out there so we know what it's trying to do. If, however, it was already in that centering mode, then it's going to go into sweep mode, and we can see that it will declare to us, I am now in sweep mode. The reason it tells us that is if at this point we still have the servo with its low value of 90 and a high value of 90, although it's sweeping from 90 to 90, so it's not going anywhere. Now, what you'll notice is I did an if statement there. So if that pin is high, do this. If that pin is not high, then we're going to read the next button. So basically, if this pin had been activated, it's not even going to look at any of the other buttons. So what I'm saying is the mode pin has priority over everything else. So once the mode pin is not being pressed, now it's going to check the adjust pin. And it goes through exactly the same thing. If that pin has been pressed, if the adjust side is greater than 0, set it to 0, and it tells us we're now going to be adjusting the low side of the movement, or we're going to be adjusting the high side. Again, we've got an if statement here, and the other end of it is here. So what we're now saying is, if the mode button's pressed, it won't read anything else, but if that hasn't been pressed, we're going to read the adjustment side pin, and if that has been pressed, we're not going to read anything else. So then we're going to move down, and it's going to read the low adjustment. This is just working over and over again. As you can see, it's a similar loop coming. You'll notice these serial prints in here. They're all commented out now for this version, but the reason I've left them in there, hopefully it gives you an insight into how I write this stuff. Before I start doing all the high-tech stuff, it's just, am I getting the buttons pressed? Is that coming out on the serial monitor? This is important parts in a project. It's very easy to dive ahead of yourself and lose where you are. So on the low adjustment pin, so this is saying that whatever side of the sweep we're doing, we're going to decrease the value, as you can see there, and it's going to go, if the adjustment side is the high side, the high set, and now we've got the limit, and obviously if I'm doing the low set, it will tell me the same. And then of course if that button hasn't been pressed, it's going to check the high adjustment. So now I've gone through all of that, let's have a look at it all in action. So let's open the serial monitor, start from fresh. Now the first button I'm going to try is the mode select. So it will have started in mode 0, so it has centered the servo. If I press it, now we're seeing it go into sweep mode, and it's sweeping from left to right. Again, both values are 90, so my servo isn't actually moving, but it gives you an idea of how it's going to be. Press the button again, and it just moves to 90 because it's gone into a stationary mode. So let's get it sweeping, and what we're going to do is I'm going to adjust the one side. So I'm going to lower the value. There you are. I'm lowering the value by pressing the one button. You can see it's still sweeping. It's going to do this in real time while the thing's moving. So now we've got a low value of 80, a high value of 90. Let's go down a little bit lower. So now we've got 73.90. Maybe I've gone too far, so I can bring that up by pressing the other button. So now we've got values of 76.90. Now if I press the second button, which adjusts which side I'm adjusting, I press that now, and now, whoops, pressed it twice. Now we're going to adjust the high side, so I'm just incrementing that, and now you'll see that the servo is now moving between those two values of 76 and 107. And basically all you do is you press those buttons while you're watching your point move backwards and forwards, and when you're happy with the movement, just write those numbers down and put them into whatever code you're going to write. Now obviously this code could be very easily adapted where you've got all these serial print statements. If you've got one of those cheap LCD monitors, you could attach LCD screens, you could attach that and have all that going onto a screen. If you wanted to build it into a little handheld unit, it'd be pretty easy to do that. But plenty of possibilities of what can be done with this. So I hope that has been useful to you. I hope it's a project that may be useful on your model railways, and if nothing else, I hope that it's useful in showing how buttons can be used to control the servo without using delay in your code, because as soon as you start putting delays in that code, you're really going to mess it up. Anyway, if it has been useful, please click the like and subscribe, because it's always one of those things that encourages you to do more videos. Bye for now.